Hello everybody, I am Nebojsa Bacanin and I work as an associate professor at Singidunum University and also as a vice dean at Faculty of Informatics and Computing of the same university. And today I'm going to briefly deliver you a presentation of our paper titled Viral Sensor Network Lifetime Optimization based on the enhanced gray wolf algorithm by Miodrag Zivkovic, Nebojsa Bacanin, Tamara, Ivana Strumberger, Tuba, and Milan Tuba. So wireless sensor networks are a type of wireless and ad hoc networks. Wireless sensor networks typically consist of a large number of tiny devices called sensor nodes. Each individual node is a cheap, small device with limited resources in terms of computing power and energy, and communication between nodes in wireless sensor network topologies is performed wirelessly. Those sensor networks are typically deployed in remote and often dangerous areas, and sensor nodes are considered to be extremely limited in available resources, so processing power, random access memory, data storage, as well as communication capabilities are scarce, to say at least, in cases of such networks. There are many problems and challenges from the domain of wireless sensor networks, like node localization problem, like the energy consumption problem, area coverage problem, and so on. However, one of the most challenging limitations by far is the energy, as the nodes are in most cases powered by the battery. Poorly selected routing algorithm would deplete the energy of the node fast, therefore rendering the complete network useless. To avoid depletion of the nodes, it is necessary to keep the communication between the nodes at a minimum level. This can be achieved by applying a routing algorithm, which is efficient in terms of minimizing the total number of transmission in the wireless sensor networks, and there are numerous techniques which can be applied to keep the nodes from dying and prolong the network time of the wireless sensor network. One traditional approach which is still in use is the clustering and hierarchical routing protocol, and in this sense we have this LEACH protocol, low energy adaptive clustering hierarchy protocol. So hierarchical routing protocol divides the network in clusters, where each cluster has a cluster head node together with other member nodes assigned to the cluster head. This cluster head will act as a sync node, collecting data from other nodes in the cluster and sending it to the base station. If the cluster head dies too early, it could shut down the complete cluster from the network. Energy efficiency and prolonged lifetime of the network can be achieved by optimal selecting and rotating the cluster head. This process, forming the clusters and selecting the cluster head, is based on the energy. So this is one typical problem that can be found in the domain of wireless sensor networks, which is called wireless sensor networks clustering problem, and this problem belongs to the group of MP-hard challenges. As we all know, MP-hard challenges cannot be solved by any traditional method or algorithm in a reasonable amount of time. So for this case, in order to solve such problems, it is necessary to use some kind of metaheuristics approach. My team and me, I have been working extensively on applying different metaheuristics approaches in order to tackle different and various MP-hard challenges. We have mostly been working with nature-inspired metaheuristics, specifically with swarm intelligence. Also in this paper, we propose one swarm intelligence approach called the gray wolf optimizer algorithm to solving this problem. The gray wolf optimizer algorithm is a relatively new swarm intelligence metaheuristics, and it proved to be very efficient and robust method for solving various MP-hard challenges. However, by performing simulation and experiments with a basic gray wolf optimizer on standard unconstrained benchmark problems, we have noticed some deficiencies, and we improved these deficiencies in using the exploration-based mechanism from other well-known swarm intelligence metaheuristic, which is called artificial big colony, or ABC. And in this way, we developed and proposed exploration and enhanced gray wolf optimizer algorithm to tackle this problem from the domain of viral sensor networks. Also, we have experience with other swarm intelligence metaheuristics, and we have been tackling many problems like radio frequency identification network problem, like cloud computing scheduling problem, like decision tree pruning problem, and so on. And most of our implementation we do in Java frameworks. However, like recently, we are gradually switching to Python because in our future research, we aim to hybridize swarm intelligence metaheuristics with different machine learning algorithms to solve, various regression, classification, clustering, and similar problems from this domain. Okay, so each node in the network is involved in data gathering and transmission of the collected data, and each node in the cluster sends collected data to the respective cluster head directly, or by some other node which is the member of the same cluster. So this clustering algorithm is applied in every round of electing the cluster head. After it is selected, the cluster head will perform data aggregation and communication with the base station for a given cluster. And the efficiency of the cluster head selection algorithm depends on the fitness function which was used in the process of choosing and electing the cluster head. So this is the problem formulation that we have used in our research. This problem formulation was also used in some other respected paper that was published in the state-of-the-art international journal that is indexed in Collaborative Analytics C-list. So this is the problem formulation. I'm not going to go deep with this formulation since we have time restrictions for this presentation. How the amount of energy required between the cluster head and the base station is given by these two equations 4 and 5. And at the end, when the total energy which is needed for transferring m bits of data from the sensor node to the base station is modeled by using this equation 6. Okay, so I'm going to give you only basic details about this gray wolf optimizer. So like any swarm intelligence metaheuristics, two basic processes that conduct the search process of gray wolf optimizer are exploitation and exploration. And also one of the greatest challenges in these algorithms is to establish a proper balance between the exploration and exploitation processes. These are the basic equations of the gray wolf optimizer that models those two search processes, exploitation or intensification and exploration or diversification. Okay, I'm not going to go in details with this. Okay, so by performing analysis on the standard gray wolf optimizer, we notice some deficiencies, and these deficiencies are that this algorithm suffers from inappropriate trade-off of balance between intensification and diversification, which is set in favor to exploitation. As a consequence of this inappropriate balance between intensification and diversification, in some runs, the algorithm may converge to suboptimal regions of the search domain, and as a consequence of this, at the end, poorer, let's say, mean values are being generated. So we wanted to, overcome this deficiency. So we incorporated a mechanism of replacing exhausted solutions from the population from the ABC metaheuristics. In this way, we have developed our exploration enhanced gray wolf optimizer. Pseudocode of this approach is given on this slide. So here we included additional control parameters in the basic gray wolf optimization algorithm. And also this exploration that was adapted from the ABC, if it is executed in all iterations during the course of algorithm's execution, it would be bad because in later stages or in later iterations, when the algorithm has converged to the optimal region, this exploration mechanism from the ABC algorithm will use cycles of algorithm, which is not necessary in this case. And for this, in order to avoid this, we have included this RPI, replacement procedure parameter, that controls whether the ABC exploration will be executed or not. Okay, so we have implemented both algorithms, the basic grade wolf optimization algorithm as well as the exploration enhanced grade wolf optimization algorithm that was proposed in this research. We have implemented both algorithms for this wireless sensor network problem, and we have compared results with the LEACH, with the basic LEACH algorithm as well as with the LEACH PSO, particles form optimization, which results were obtained from the paper that was published in the state-of-the-art journal. Okay, I also should emphasize that the basic grade wolf optimizer implementation was not found in the literature for this particular problem. So in order to compare results of our enhanced version of the grade wolf optimizer, we also have implemented the basic grade wolf optimizer for this particular problem. Okay, here are the results. So as can be seen from this results table, this LEACH exploration enhanced grade wolf optimizer managed to keep alive all the nodes for 3,900 iterations. Compared to our proposed approach, the LEACH particles form optimization managed to keep alive all nodes till 3880th iteration. Also, it is interesting to compare the performance of the basic grade wolf optimizer and our proposed exploration enhanced grade wolf optimizer, and the performance difference can be noticed. You see this basic grade wolf optimizer managed to keep nodes alive till the 700 iterations, while our exploration enhanced grade wolf optimizer managed to keep nodes alive till the 3900 iteration. So performance differences are significant in this case, and also, as we can see from this table too, when you compare the packet sends to the base station, we can see that our proposed approach is able to send 21,000 packets to the base station. Okay, as I have already noted, all our implementations are in Java, and we have developed extensive simulation framework in Java for testing various swarm intelligence metaheuristics for different MP-hard challenges. So as a conclusion, we can see that our proposed approach can obtain significantly better results than other approaches that are shown in the literature for this particular problem. And also, I should say that this grade wolf optimizer is very promising metaheuristics, and we plan in our future research to implement this algorithm for other MP-hard challenges as well, also from the domain of wireless sensor networks and also from some other domains. So at the end, we have one question that was posted by one esteemed reviewer. The question is, can you discuss your approach in the context of nodes based on the upcoming 5G technology? So one of the uses on a 5G network is massive Internet of Things, which includes the massive machine-type communication with low cost, long distance, long power, and broadband machine-type communication. One case of machine-type communication is wireless sensor networks. In the wireless sensor networks, as we all know, device sensors will be deployed in mostly urban areas with good 5G coverage. High-altitude platform wireless sensor network system configuration, or HAP system, is used to replace the ZINC node. It works on the two levels. First level is so-called level A. Sensor nodes in the HAP cell shall be directed to HAP, and the level B. Sensor nodes in HAP cells are arranged in a cluster where one node with a higher level energy compared to other nodes is appointed the cluster head. As we can see, our approach can be directly applied to the level B, as it is still relying on the LEACH protocol to select the cluster heads based on the available energy. I hope this answer is satisfactory, and thank you for posing this question. So if you have any questions or if you have an idea for a joint project, please contact me at this email, Bacanin@singidunum.ac.rs, or via this phone number. So this presentation was very short because we have time limitations. I wasn't able in those 15 or 20 minutes, I don't know, to give you all the details of our research. So if you want to get more insights into our research, please send me email or call me on this number, and I will gladly share all information with you. So thank you very much. Thank you for your attention, and thank you for this extraordinary conference. So see you in some other event. Bye. Thank you.